In this lesson, we are going to look at adding and subtracting algebraic fractions. We all know what fractions are. Let's consider two fractions, a over b and c over d. How do we actually work out a over b plus c over d, or a over b minus c over d? Now, you need to recall that for a fraction, a over b, this is called the numerator, and this is the denominator. Alright, what we need to do to actually add a over b and c over d is actually we need to rewrite a over b and c over d with the same denominator. Once we have the same denominator, we can actually add them together or subtract them. Now, let's have a look at this case. The lowest common denominator is actually b times d, or bd. So in order to rewrite ab with the common denominator of bd, we multiply ab by d over d, which gives us ad over bd. And for cd, we multiply cd by b over b, which gives us bc over bd. C, in this case, the common denominator for both of them, they are actually bd. Alright? So therefore, ab plus a over b plus c over d is actually ad plus bc over bd. The same procedure actually applies to a over b minus c over d. Again, express ab and cd with the lowest common denominator, and therefore this is the answer. Alright, let's have a look at some numerical examples. First, 5 over 12 plus 3 over 8. Let's have a look at 12 and 8. What actually is the lowest common denominator? It's actually 24. 12 times 2 is 24, and 8 times 3 equals to 24. Alright, of course, if you like, you can use other denominators such as 48, but in this case, I'm going to use the lowest common denominator. Rewriting 5 over 12 to the lowest common denominator. So we do 5 over 12 times 2 over 2 plus 3 over 8 times 3 over 3. Because 12 times 2 gives us the lowest common denominator of 24, and 8 times 3 gives us 24. Now, rewriting this is actually 5 times 2 is 10, 12 times 2 is 24, plus 3 times 3, 9. 8 times 3 is 24. Therefore, that's 24. 10 plus 9 and equals to 19 over 24. Alright, what about minus? What do we do with this? What is the lowest common denominator of 7 and 5? In fact, is 35, which means 7 times 5. So, in this case, we've got 4 over 7 times 5 over 5 minus 2 over 5 times 7 over 7. Alright, so 4 times 5 is 20, 7 times 5 is 35, minus 2 times 7 is 14, 5 times 7 is 35. Therefore, that equals 20 minus 14, which is 6 over 35. The same procedure can be actually applied to algebraic expression as well. Alright, so let's have a look at how we do it. Okay, first, let's consider 2x over 5 plus 3x over 8. What is the common denominator for 5 and 8? 5 and 8. It's actually 5 times 8, which is 40. So, rewriting 2x over 5 and 3x over 8 using the lowest common denominator. So 2x over 5 actually multiplies by 8 times 8 plus 3x over 8 times 5 over 5. That gives you 2 times 8 is 16x over 40 plus 15x over 40. Therefore, that's 31x over 40. Alright, I want you to pause the video for a couple of minutes and try to work out this. I think you've got enough time now. Let's have a look at how do we add these two together. What is the lowest common denominator of 3 and 4? In fact, it is actually 12. So 3 times 4 equals to 12. We have minus 2k over 3 times 4 over 4 plus 3k over 4 times 3 over 3, which means 2 times 4 is 8k over 12 is still minus, plus 3 times 3 is 9k over 12. 4 times 3 is 12. Therefore, we've got minus 8k plus 9k all over 12, and that is actually k over 12. Alright, this is how you do it when you've got numbers as the denominator. Now, I'm going to show you examples with expressions, with pronumerals as the denominator. How do we go about doing this? It's actually the same procedure as well. Alright? We will find the lowest common denominator for this, x and 5x. What is it? X and 5x. The lowest common denominator is actually 5x. So 5 over x times 5 over 5 plus 3 over 5x. We don't actually need to change that. We need to bring that up to 5x. Therefore, that equals to 25 over 5x plus 3 over 5x. That gives us 28 over 5x. That's it. That's the answer. We'll leave it there. What about the next one? You've got 7x and x squared. What actually is the common denominator for this? 7x and x squared? In fact, it's actually 7x squared. Alright? Now, to get from 7x to 7x squared, you multiply it by x. To get from x squared to 7x squared, you multiply x squared by 7. So therefore, rewriting this, 4 over 7x times x times x plus 3 over x squared times 7 over 7. Therefore, you got 4x over 7x squared plus 3 times 7 is 21 over 7x squared, which means you have 4x plus 21 over 7x squared. Okay, now to another example. This time, you've got x minus 1 as the denominator and x plus 2 as the denominator here. What is the common factor for x minus 1 and x plus 2? In fact, it is just x minus 1 times x plus 2. So therefore, to get from x minus 1 to that, we multiply it by x plus 2. To get from that to that, we multiply x plus 2 by x minus 1. Rewriting this, equals to 6 over x minus 1 times x plus 2 over x plus 2 minus 1 over x plus 2 times x minus 1, x minus 1. Therefore, you have x minus 1, x plus 2. You got 6x plus 2 minus x minus 1. That's all. You leave it at there. Right, let's look at a few more examples. Look at this. What actually is the common denominator between x minus 2 and 2 minus x? Now, let's have a look. If we multiply 2 minus x by minus 1, what we have is minus 2 plus x, which is actually x minus 2. Alright, therefore we can rewrite this as 4 over x minus 2 plus 3 minus 1 times 2 minus x. Or you can rewrite this as 4 over x minus 2 minus 3 over x minus 2. Therefore, it's x minus 2 as the denominator, 4 minus 3. That equals to 1 over x minus 2. Alright, this is just looking and trying to work out what you can use the minus 1 for. Alright, what about this one? You've got x minus 2 and x plus 1 in the first term. X minus 2, x plus 1. Okay, what about this one? You've got x plus 1, x minus 3. Therefore, if we combine all of it, the lowest common denominator, or actually just the common denominator in this case will do, is actually x minus 2 and x plus 1 and x minus 3. Alright? Okay, I'm running out of space here, so I'm actually going to use here. This will give us 2, x minus 2, x plus 1. We are missing an x minus 3, okay? X minus 3, x minus 3, plus x plus 1, x minus 3 here, 5. We are missing a x minus 2. Therefore, we can rewrite this 2 x minus 3 plus 5 x minus 2. Because we've got the same denominator now, it's x plus 1, x minus 2, x minus 3. That is the answer. So one last one for you to actually look at. How are we going to do this? I'm going to give you about 30 seconds. Think about it. See how you could actually solve this. Right, let's look at this problem. How do we add these two together? 4 over c squared minus 3c minus 18 plus 2 over c squared plus 5c plus 6. We can actually bring these two into common denominator by actually factorizing this denominator and that denominator. Let's have a look at the first one. What actually is how could we factor this? What two numbers give you minus 8 and add them together gives you minus 3? It's actually minus 6 and plus 3. So we've got c minus 6 and c plus 3. We don't change the numerator, which is 4. What about this one? What is it? 2 times 3 gives you 6 and 2 plus 3 gives you 5. So it's plus 2 plus 3, and that's 2. Now again, let's look at the common denominator. What would the common denominator be? C minus 6, C plus 3, and C plus 2. So we have 4 over C minus 6, C plus 3. What is missing? C plus 2. C plus 2, C plus 2. Plus 2 over C plus 2, C plus 3. What is missing is C minus 6. Rewriting is 4 C plus 2 plus 2 C minus 6. Because they have all got common denominator, we can rewrite it as C plus 2, C plus 3, and C minus 6. And that's it. That's how you add these two algebraic fraction. Alright, this is a lesson on how to add algebraic fractions. Let's do some exercises from your book.